Yes, good afternoon, students. I am Dr. Vikas Gupta, Professor and Head Department of Electronics and Communication, Technocrats Institute of Technology, Bhopal. Today, I am giving presentation on our subject microengineering. It is EC 702A. I am giving the presentation on Unit 1. In the last class, we have discussed about the different microwave junction. Microwave junction is nothing but a combination of waveguides. In the last class, we have discussed the H plane T. Now, in this class, I am going to discuss the E plane T junction. Firstly, I am going to discuss what is E plane T. An E plane T junction is formed by attaching a simple waveguide to a broader dimension of the main waveguide. See, students, we are having the main waveguide, which is a rectangular waveguide. In that main rectangular waveguide, which has two ports, port 1 and port 2, we are attaching an auxiliary guide. Auxiliary guide as a side arm, which form a side arm or E arm. The two ports which already rectangular waveguide is having, those are known as the port 1 and port 2. The auxiliary guide is attached to the side arm or E arm of the main waveguide to form a E plane T junction. E plane T junction is also known as the series T. This type of diagram we can have. These are the port 1 and port 2 are combinedly consisting of the main waveguide, and we are having the port 3. We are having the port 3 as a side arm. So it is a 3-port junction. It is a 3-port junction. This is the physical diagram you can see. And E plane T, here I have written that E plane T junction is formed by cutting a rectangular slot along the breadth of the main waveguide and attaching another waveguide, the side arm called the E arm, okay, to form a E plane T junction. In the way we have discussed about the H plane T junction. See, students, H plane T junction, I have already discussed that H plane T junction is formed by cutting a rectangular slot along the width of the main waveguide and forming a 3-port junction. Likewise, we are having the E plane T junction. We can have the EH plane T junction also, that we are going to discuss in our next lecture. So in this E plane T junction, so this is the physical diagram of the E plane T junction, students. Okay, now I'm going to discuss the scattering matrix of the E plane T junction. See, students, we are going to discuss the scattering matrix. We are knowing that since it is a 3-port junction, it is having 3 possible inputs and 3 possible outputs. Hence, the microwave scattering matrix will be having the 9 ports as S11, S12, S13, S21, S22, S23, S31, S32, S33. So this is the required scattering matrix which is to be prepared. Okay, it is consisting of 3 ports, hence it will be a 3x3 junction, 3x3 scattering matrix. Okay, we are knowing that if for an n-port junction, we are having a scattering matrix. We are having a scattering matrix of n cross n. Likewise, for a 3-port junction, it will be a 3x3 scattering matrix. Okay, it is having the 9 elements, and these are the 9 elements. Okay, now with the help of different properties of the scattering matrix, we'll reduce this matrix. Whatever matrix we are having, we are going to reduce this matrix as S13 and S23 in this scattering matrix. In this generalized scattering matrix, S13 and S23 are equal, because, see, students, we are knowing that whatever is a power which is being input from port 3, it will be divided between port 1 and port 2 in equal amount. Okay, in equal amount and opposite phase. Okay, so that two scattering coefficient. Okay, we'll talk about S13 and S23. We can say like this: S23 will be equal to S minus S13. it is in accordance with our property. Whatever be the input from port 3, it will be equally divided between port 1 and port 2, but in opposite phase. Hence, S13 will be equal to minus of S23. So this is the first interpretation we are having. And the very important interpretation which we can have about the symmetric property of the scattering matrix. We are knowing that the scattering coefficient follow the or I can say the scattering matrix follow the symmetric property. Symmetric property means Sij is always equal to Sji, like S12 is equal to S21, S23 is equal to S32, and we are knowing that S23 is equal to minus S13. So we can write like this: S23 is equal to S32, it is equal to minus S13, and S13 is equal to S31. So we can reduce this. We can reduce this like yes. So these are the different properties, and accordingly we have reduced the scattering coefficient. Like for scattering coefficient S23 and S13, they are equal and opposite. Hence S23 will be equal to minus S13. Okay. The port 3, whatever is a port 3 which is being arbitrarily, which is being attached to the main waveguide, the port 3 is always in perfectly matched condition. Port 3 is always in a perfectly matched condition. Hence, we can say S33 will be equal to 0. S33 is always equal to 0 because port 3 is perfectly matched to the junction. That means whatever is the input from port 3, there will be no output from port 3. And there will be a equal and opposite output from port 1 and port 2. Since it is equal and opposite, hence we can say S13 is equal to minus S23 and S33 will be equal to 0. So according to discussion of these two properties, we can write like S23 is equal to minus S13 and S33 is equal to 0. And according to the symmetric property of the scattering matrix, we can say like S12 is equal to S21, S23 is equal to S32, S13 is equal to minus S31. By using all these scattering coefficient, by using all the scattering coefficient in the reduced value, the reduced scattering matrix will look like this. It will be consisting of S11. In place of S11, we'll write S11 only. In place of S12, we'll write S12 only. In place of S13, we'll write S13 only. In place of S21, we'll write S12. In place of S22, we'll write S22. In place of S23, we'll write minus S13. In place of S31, we'll write S13. In place of S32, we'll write minus S13, and the last coefficient S33 will be equal to 0. So this is a reduced matrix we are having. Students, now we are interested with these many different scattering coefficient as S11, S12, S13, and S22. These are the 4 unknown values which is to be calculated. Okay. So what we are going to do, we are going to apply the unitary property of scattering matrix. Unitary property states? Unitary property states like this, that multiplication of a scattering matrix along with the complex conjugates of the scattering matrix will be equal to the identity matrix. S into S conjugate is equal to I. So we are writing like this. We are having the scattering matrix S matrix. We'll take the complex conjugate of the different coefficient as S11 conjugate, S12 conjugate, S13 conjugate, S12 conjugate, S22 conjugate, S minus S13 conjugate, S13 conjugate minus S13 conjugate 0. It is equal to the identity matrix. Now, since students, we are having 4 unknowns which are to be calculated, we are going to use the 4 equations. Okay. We are going to design the 4 equation. We are going to write the 4 equation. Those 4 equation will look like this. We are going to multiply row 1 and column 1. R1, C1, if we'll calculate, we'll be having S11 into S11 conjugate plus S12 into S12 conjugate plus S13 into S13 conjugate is equal to 0, is equal to 1, sorry, is equal to 1. At the right hand side, it is 1. So we'll write S11 mod square plus S12 mod square plus S13 mod square is equal to 0. Since we can write like this. This is S11. Now this is all about R11. Now we'll talk about R2C2. R1C1 we have calculated. Now we'll talk about R2C2. For R2C2, we'll be having S12 mod square plus S22 mod square plus S13 mod square is equal to 1. We'll talk about R3C3. It will be S13 mod square plus S13 mod square is equal to 1. And we are going to calculate one more equation as S13 into S11. We are going to calculate R3C1, row 3, multiplication of row 3 and column 1. We are going to multiply row 3 and column 1. Okay. If we'll do row 3 and column 1, what it will be having, that I'll let you know. Yes, student. See, see, we'll do R3C1. We'll be having the equation S13 into S11 conjugate minus S13 into S12 conjugate is equal to 1. If we take S13 as a common in these two, we'll get S11 minus S12 is equal to 0. S13 is not equal to 0 because from equation number 8, if we'll calculate S13, we'll get S13 is equal to 1 by root 2. S13 is equal to 1 by root 2. And in this equation number 9, if we'll take S13 out of the bracket, we can write S11 minus S12 is equal to 1. S13 is see student, R3C1. If we'll take row 3 column 1 value, it is 1. Okay, so these are the 4 equations with which we are going to calculate all the unknowns. If we calculate the unknowns, we get S13 is equal to 1 by root 2, the first value. Okay, now see student, R3C1, the right hand side of the R3C1 of the identity matrix, it is 0. By using this equation number 9, we can write S11 is equal to S22. Okay, S11 S11 is equal to S11 is equal to S12, and by equation number 6 and 7, we can write S11 is equal to S22. By using this equation, we can write S11 is equal to 1 by 2. Since students, S11 is equal to 1 by 2, definitely S12 is equal to 1 by 2. And S22 will also be equal to 1 by 2. S13 is equal to 1 by root 2. It will put all these equations in our previous matrix, what we are having as a reduced matrix, equation number 5. If we'll put all these, if we'll put all these value, we'll get the reduced scattering matrix like this. Scattering matrix S is equal to 1 by 2, 1 by 2, 1 by root 2, 1 by 2, 1 by 2, minus 1 by root 2, 1 by root 2, minus 1 by root 2, 0. So this is a scattering matrix of a E-plane T junction. So students, are you all getting? If we'll put the different values, of different scattering coefficient, we are getting the scattering matrix like this. It is 1 by 2, 1 by 2, 1 by root 2, 1 by 2, 1 by 2, minus 1 by root 2, 1 by root 2, minus 1 by root 2, 0. This is the scattering matrix of a E-plane T junction. And now if we'll calculate the reflected coefficient, see students, in our scattering matrix discussion, we have already discussed that B is equal to S into A. And what is B matrix? See students, you can see this equation. We know that B is equal to S into A. Okay, and you all should know what is B. What is B? So I'll tell you, B is a column matrix corresponding to reflected coefficient, and S is a scattering matrix, and A is a column matrix corresponding to the incident elements. Hence, we can write B in place of B, we'll write B1, B2, B3. S is a scattering coefficient, scattering matrix. We'll put scattering matrix as it is, and A is a column matrix corresponding to the incident elements. It will be A1, A2, A3. It will be A1, A2, A3. Hence, we can have 3 equations of B1, B2, and B3. Now, I'm going to write those 3 equations, student. See, we are going to write those 3 equations. This is the value of B1. See student, according to the general property of the matrix, we know that B1 is equal to 1 by 2A1 plus 1 by 2A2 minus 1 by plus 1 by root 2 A3. B2 is equal to 1 by 2A1 plus 1 by 2A2 minus 1 by root 2 A3. B3 is equal to 1 by root 2A1 minus 1 by root 2 A2. So these are the different values of the reflected coefficient in terms of the incident coefficient. So this is all about the E plane T junction. Are you all getting? Student, this is E plane T junction. This is a scattering matrix of the E plane T junction. So up till now, I have discussed H plane T junction and E plane T junction. Now I am going to discuss the EH plane T junction. So student, this is all about E plane T junction. This is the reflected matrix, column matrix corresponding to reflected element. This is the scattering matrix, and this is the column matrix corresponding to the incident elements. Now I am going to discuss the EH plane T. So this is all about E plane T. I have discussed H plane T. I have discussed E plane T. Now I am going to discuss EH plane T. So students, our next discussion is about EH plane T. We are going to discuss EH plane T. Yes, students, we are going to discuss EH plane T. What is EH plane T? From this, I am going to start. Firstly, EH plane T. As we have discussed for H plane T, H plane T is a junction which is formed by cutting a rectangular slot along the wider dimension of the main waveguide and attaching an auxiliary guide to form the 3-port junction. Likewise, we are having the E plane T junction, which is formed by attaching an auxiliary guide along the broader dimension of the main waveguide. If we'll attach two auxiliary guide to the main waveguide in wider as well as on the broader dimension to form a 4-port junction, it will be known as the EH plane T. So now students, firstly, I'm going to discuss what exactly EH plane T. EH plane T is formed by attaching two simple waveguide, one parallel and other series to a rectangular waveguide, which has already 2 ports to form a magic T or a hybrid T. It is known as magic T. Why it is known as magic, that I'm also going to discuss. What is magic in this T? It is also known as the hybrid T. It is also known as the EH plane T. So students, I'm going to show you the diagram for this so you can have the better understanding of this. So this is a 4-port junction, student. This is the main waveguide. Port 1 and port 2 is forming the main waveguide. We have attached an auxiliary guide to the wider dimension of the main waveguide which is known as the H arm. Likewise, we have attached an auxiliary guide to the broader dimension of the main waveguide, which is known as the E arm. Okay. For H arm, we are preparing a port 3, and for E arm, we are preparing a port 4. Hence, it will be a 4-port junction. See, student, main waveguide is forming 2 ports, port 1 and port 2, and 2 auxiliary guides are preparing 2 more ports at port 3 and port 4. So we are having a 4-port junction. This is known as the EH plane T or a magic T. This is a physical diagram of a EH plane T. You can be able to see this. It is a 4-port junction. It is having properties of E plane T as well as the H plane T. See, students, this port 1 and port 2 are known as the collinear ports. This is known as the collinear arm, and the port 3 is the arm forming a port 3 is known as the H arm, and the arm which is forming a port 4 is known as the E arm. So it is a 4-port junction we are having. This I have already written, that the arms of a rectangular waveguide making 2 ports are called collinear port, port 1 and port 2. Port 3 is known as the H arm or sum port or parallel port. Port 4 is known as the E arm or difference port or series port. that I'm going to discuss why it is known as difference port, why it is known as series port. The cross-sectional details of a magic tea can be understood by the following diagram. This is a diagram which I want to tell you. You can be able to see this. You can be able to visualize this magic tea. What exactly it is? It is a magic tea. It is a EH plane tea. So now I'm going to discuss the characteristic of this magic tea. So student, the first and foremost characteristic which we have discussed in H-arm discussion, that whatever is the input from port 3, there will be equal output from port 1 and port 2. That means whatever is the power input from port 3, it will be equally divided between port 1 and port 2, and that too in a same phase. Whatever is the input from port 3, it will be equally divided between port 2 and port 1 and port 2, and in equal amount and same phase. This is the first and foremost property. If a signal of equal phase and magnitude is sent to port 1 and port 2, then output at port 4 is 0. Output at port 3 will be the additive sum of both the port 1 and port 2. This is the same thing which I am telling you. Whatever is the input from port 3, there will be no output from port 3, and the output from port 1 and port 2 are of equal value and same phase. Conversely, we can say like this also, if whatever is the input from port 1 and port 2, it will be added up when it will come out from port 3. This I have written, that if a signal of equal phase and magnitude is sent to port 1 and port 2, then output at port 4 is 0. Port 4 definitely 0 rahega. For output at port 3 will be the additive of both the output from port 1 and port 2. Likewise, if the signal is sent from port 4, the output from port 1 and port 2 will be of equal value and opposite phase, and there will be no output from port 4. Likewise, similarly, we have discussed for port 3, there will be no output from port 3. But the input from port 1 will be equally divided between port 1 and port 2, but in opposite phase. So these are the property of this EH plane T, and mind it student, this property will help us to prepare the scattering matrix of the magic T. Okay, so this is the first statement which I have read, and you people are probably able to understand. The second is, if the signal is sent to port 4 E-arm, then the power is divided between port 1 and port 2 equally, but in opposite phase, while there should be no output from port 3. Hence S34 is equal to 0. Likewise, if a signal is fed at port 3, then the power is divided between port 1 and port 2 equally, while there will be no output at port 4. That means S43 is equal to 0. So students, since it is a 4-port junction, we are going to prepare the scattering matrix of this 4-port junction. It will be the blank matrix which will be having, it will be a 4x4 matrix. It will be a 4x4 matrix consisting of 16 elements as S11, S12, S13, S14, S21, S22, S23, S24, S31, S32, S33, S34, S41, S42, S43, S44. So these are the scattering coefficient. Now, according to H plane T junction section, according to our property of H plane T, we can say that input from port 3 will be equally divided. See student, input from port 3 will be equally divided between port 1 and port 2, and of equal value. Okay, so we can say S23 is equal to S13. Whatever is the input from port 4, it will be equally divided between port 1 and port 2, but in opposite phase. So we can say S24 is equal to minus S14. See, these E-arm and H-arm are themselves, they are the isolated ports. There will be no input from port 4 if there is an input from port 3. And if there is an input from port 4, there will be no output from port 3. That means these are the independent ports, and S34 is equal to S43 is equal to 0. Now we are going to apply the symmetric property as we have applied for E plane T junction and H plane T junction. Symmetric property of scattering matrix will be having S12 is equal to S21, S13 is equal to S31, S14 is equal to S41, S23 is equal to S32, S24 is equal to S42, S34 is equal to S43. If port 3 and port 4 are perfectly matched to the junction, since we are knowing that whatever is the auxiliary port, they are always attached in a perfectly matched condition, hence S33 is equal to S44 is equal to 0. Substituting all these values, we'll be having the reduced matrix. This is equation number 7, which is representing the reduced matrix. Now, student, we are going to calculate the scattering coefficient. Are you all getting? Yeah, up till now, we are having the reduced matrix. Now, according to the unitary property of scattering matrix, we are knowing that S into S conjugate is equal to I. So what we are going to do, we are going to take the original, we are going to take this reduced matrix along with the multiplication of one more matrix, which is nothing but elements having the complex conjugate value. And the product of this two is equal to the identity matrix. So we have written like this. And now we are having some unknowns. We have to search how many unknowns are there. So definitely, students, you can be able to see we are having 5 unknowns with us. We are having 5 unknowns as S11, S12, S13, S14, and S22. These are the 5 unknowns which has to be calculated. Hence, 5 equations are required. So according to the matrix property, we are going to multiply R1 and column 1, R1 from the first matrix and column 1 from the second matrix. R1 C1 will do, and R1 C1 at the right hand side, it is having the value 1. So equation number 8, we are having R1 C1, it is S11 mod square plus S12 mod square plus S13 mod square is equal to 1. Likewise, we are having R2 C2. We can say like this: S12 mod square plus S22 mod square plus S13 mod square is equal to 1. We are having R3 C3 as our S13 mod square plus S13 mod square is equal to 1. We are having R4 C4 as S14 mod square plus S14 mod square is equal to 1. By equation number 10 and 11, we can directly calculate S13. S13 is equal to 1 by root 2 and S14 is equal to 1 by root 2. Now, if we'll compare equation 8 and 9, see students, equation 8 and 9, if we'll compare, we can directly say that S11 is equal to S22. Now, if S11 and S22 are equal and S13 and S14 are having value 1 by root 2, 1 by root 2. So from equation number 8, what we can say, S11 we'll write S11 mod square only. S in place of S12 we'll write S12 mod square only. The S in place of S13 we'll write 1 by root 2. In place of S14 we'll be write 1 by root 2. Now, since S11 and S12 are equal, so what we can say, S11 and S12 are equal, we can say that by using this, we can directly get that S11 is equal to S22 is equal to 0. That means we have, see student, if we are getting S22 is equal to 0, what interpretation we can get? We can interpret it like this: since S11 is equal to 0, S33 is equal to 0, S44 is equal to 0, S22 and S11 are by default coming out to be 0. This is the magic in this property. That means, are you all getting what is the meaning of S11 is equal to 0? S11 is equal to 0. That means that port 1 is perfectly matched to the junction. S22 is equal to 0. That shows that port 2 is perfectly matched to the junction. S33 and S44 are already equal to 0. That means if in any 4-port junction, if we'll take 2 scattering coefficient, or we can say if we'll take 2 ports perfectly matched to the junction, the remaining 2 ports become automatically be matched to the junction. This is magic in this T. I've written also that if in a 4-port junction, if 2 ports are perfectly matched to the junction, the remaining 2 ports become automatically be matched to the junction. Automatically matched to the junction. This is magic in this T. And by using different equation, we can have the matrix, scattering matrix of the magic T. This is the scattering matrix of the magic T. And if we'll insert, it will put this scattering matrix value into our equation B is equal to S into A. This is the equation for this magic T. This right hand side B1, B2, B3, B4 is a column matrix corresponding to reflected wave. A1, A2, A3, A4 is a column matrix corresponding to incident wave, and this middle one is a scattering matrix. This middle one is a scattering matrix. We can calculate the value of B1, B2, B3, B4 likewise as we have calculated for that E plane T. B1 is B2. The first equation will be B3 is equal to S12 A1 S12 A3 plus 1 by B3 is equal to 1 by 2 A3 plus 1 by root 2 A4. Likewise, we are having the four equations of B1, B2, B3, B4, and we are now this is all about the scattering matrix of EH plane T. Now I'm going to discuss the applications of EH plane T or magic T. EH plane T are having the various applications. EH plane T junction is used to measure the impedance of any junction. EH plane T is used as a duplexer. EH plane T is used as a mixer. So these are the different applications of magic T. These are the different applications of magic T. So student, this is all about the magic T. So up till now I have discussed the microwave junction, in which I have discussed E plane T, H plane T and EH plane T, which is magic T. In the next class, in the next video lecture, I am going to discuss the directional coupler, different other microwave junctions like directional coupler and different couplers and different we are going to discuss the ferrite devices also. So this is all about this class. So students, thank you for today's class.